Assalamualaikum everyone. So today we'll be solving P3 January 2025 paper for A levels. So without further ado, let's dive right in. So in the first equation we have a function which looks like this. The equation if x equals 0 has a single root alpha. Show that alpha lies between 0.1 and 0.2. Okay, so a root means basically the definition of a root is that it cuts the x-axis. So let's just assume that the graph looks like this. Now let's say that this is 0.1 and this is 0.2. So this will be our alpha. Now alpha lies between 0.2 and 0.1, but how can we prove that? So if this is the equation of fx, which means that if I substitute x equals 0.2 into this equation, we will get a positive y value. So that's a positive y. And if I substitute x equals 0.1 into the equation, we will get a negative y value, which is negative y. So this is how we will prove that alpha lies between 0.2 and 0.1. So this is how you usually show that a root lies between any two values. So for the first one, we need to substitute x equals 0.1. So it gives us a negative value, which is negative 0.39. And then we will substitute x equals 0.2, which is 0.24, which gives us a positive value. So we need to state two things. The first thing is that there is a change in sign. So this is important. There is a change in sign. And the second thing we need to state is that the function is continuous. So we need to say that there is a change in sign. So this is a continuous function, which means that there's a range of values of x. There's hundreds of range of values of x. There's a change in sign, and fx is continuous. So alpha lies between 0.1 and 0.2. So that is the answer. Now for the second part, we need to show that alpha is a solution of x equals half minus 1/3 cos x. So basically we need to solve this equation if x equals 0. So if we solve this, if x equals 0, which means 2 sec x plus 6x minus 3 equals 0. Alright. So basically we need to make x the subject, not this x, that is for cos x. We don't need to make cos x the subject. We need to make this x, which is, they're talking about this variable x. So the first thing we need to do is that okay, so if we make x the subject, so this is 3 minus 2 sec x. So the value of x can be written as 3/6 minus 2 sec x over 6. So 3/6 gives us a value of 1/2, and 2/6 gives us 1/3. Now the thing is that you can write sec x as 1/cos x. This is a trigonometric identity. You need to memorize this. So this can be written as 1/3 cos x. So that is the answer for this part. Now for the next question, the iterative formula is given. So this iterative formula is used to find alpha, and starting with x1 equals 0.15, so we have the value of x1 to be 0.15. So the first question is to find out the value of x2. So if we use that iterative formula, we can say that x2 can be written as x1 plus 1. So the value of n is actually 1. So this is equals to 1 over 2 minus 1 over 3 cos xn, which is x1. We know the value of x1 to be 0.15. So this is x2. So this gives us a value of 0.1629. So that is it for this part. Now moving on to the next part, we need to find out the value of alpha. So in order to solve questions like this, you would first need to draw a table. I mean, you do not need to draw a table in your answer script. You can just do it in a rough page, or you can create a table in your calculator. But to understand it, let's just draw the table. So the table should look something like this. So this column will represent xn, and this column will represent the fx, or basically xn plus 1, the value of xn plus 1. So when the value of xn is x1, which is x2, or you can just create the table like this. Let's say that we have the function which is gx as 1 over 2, which is the iterative formula. Basically it's the iterative formula, which is 1 over 2 minus 1 over 3 cos xn. That's 1 over 3 cos xn, and this will be the value of xn, and this will represent the value of gx. So when the value of xn is 0.15, the value of gx was 0.1629. 0.1629. Now keep in mind that this is the value of x2. You need to substitute this value into the gx equation again to get x3. So for the next row, this will be 0.1629. so this gives us a value of 0.1622, and then you need to substitute this into gx, which is 0.1622. Now you keep substituting these values until there's no change in decimal places. Let me show you that in this part this is 0.1622. Now as you can see that we have to write the answer to 4 decimal places. So 4 decimal places is this value. Now as you can see that these 2 digits repeated itself twice. So this is when you should stop your iteration. So the value of alpha is 0.1622, corrected to 4 decimal places. So this is how you usually find out the roots using an iterative formula they have given. So that is it for this question. So in the previous video, we have solved the question 1 of P3 January 2025 session. Now let's move on to the second question. So the width on the surface of a pond is being monitored. The surface area is covered by the width is a meters squared. Is modeled by the equation this. So t actually represents the time in number of weeks after monitoring began. Now we just need to find the surface area of the pond initially covered by the width. Initially means that the value of t is 0. So if we substitute the value of t as 0 into the equation, so this gives us log 10a equals 1 plus 0, so it's basically 1. Now we know that in log, if you bring this base of the log to the right hand side of the equation, this one becomes the power and this one becomes the base of the power. So let me just show you. So it's a equals 10 to the power 1. So if we have something which looks like this, that log xy equals z, we can write it like this: y equals x to the powered z. So this is actually a formula for logarithms. Alright. So the surface area which is initially covered by the pond, by the width, is 10 meters per meter squared. So that is the answer to part A. Now for part B, after t weeks, 25 meters squared of the pond is covered by the width. Find the value of t. So when the value of t is capital T, the value of A is 25. Now we just need to find this value of t. So if I substitute these values into the equation, so this will give us log 10 25 equals 1 plus 0.03t. Now we just need to find out the value of t. So in order for that, we need to make t the subject. So making t the subject will give us log 10 25 minus 1 divided by 0.03. So this gives us a value of so we need to give the answer to 2 decimal places. So this gives us a value of 13.26. Now the value of t is the number of weeks. So it's 13.26 weeks. So that is the answer for the second question. So in the previous video we have solved the question 2 of P3 January 2025 session. Now let's move on to the question 3. So a curve has an equation this, and the domain is also given. Use calculus to find the range of values of x for which y is increasing. So if a function, or if an equation, basically, which is in this case it's y, if a function is increasing, always remember that if fx is increasing, it means that the value of f prime x is greater than 0. And if fx is decreasing, let's assume that if fx is decreasing, the value of f prime x will be less than 0. So in this case, this is increasing, which means f prime x will be greater than 0. So since this is in the y format, in this case this will be dy over dx will be greater than 0. Alright, so now let's continue with the maths. So we need to find the value of dy over dx. So first of all, you can differentiate this in two ways. First of all, using the product rule, and the second of all, which is the quotient rule. So let's just use quotient rule for this one. Let's say that this is u and this is v. So we know that the value of dy over dx will be v du by dx. So it's x plus 3 whole square du by dx. Differentiating this one will give us 4. So it's 4x plus 3 whole squared minus u dv by dx. So u is 4x plus 1, and dv by dx will give us, so if we have something which looks like this, that fx to the powered n, if we differentiate this, this will give us n f prime x times fx to the powered n minus 1. So you can think of this like a formula. So what happens is that this power comes to the front side. So it's 2 times, and then we differentiate the function in the middle part. So this will give us 1, and then what we do is that subtract 1 from the power. So it's 2 minus 1, which is 1, divided by v squared. So this is the quotient rule, divided by v squared, which is x plus 3 to the power 4. Now let's simplify this so that this becomes much easier. So if we simplify this value, this will be minus 2x plus 3. And if you take x plus 3 as common from the numerator, because x plus 3 is in both of these terms, so this will be 4x plus 12 minus 8x minus 2 divided by x plus 3 to the power 4. Now what we can do is that we can cancel out these terms, so this becomes 3. So the final answer will be minus 10 minus 4x divided by x plus 3 cubed. So that is it for this one. Now we just need to find the range of values of x, which means dy over dx is greater than 0. So we can write this equation as 10 minus 4x times x plus 3 to the power negative 3 is greater than 0, because we know that dy over dx is greater than 0, since this is an increasing function. Now in order to solve these inequalities, we need to find the critical values. Critical values as in, we need to set this equation to 0 so we can find out the values of x. So one of the values of x will be 5 over 2 and the other one will be negative 3. Now we need to solve the inequality as dy over dx is greater than 0. Now as you can see that x cannot be equal to negative 3, because it's given in the domain that x cannot be negative 3. So x must be greater than negative 3 but less than 5 over 2. So the inequality is x must be greater than negative 3 but less than 5 over 2. So this is the range of values of x for which c is an increasing function. So that is it for this question. So in the previous question we have solved the question 3 of P3 January 2025 session. Now let's move on to question 4. So given that this fraction can be written in this format, now we just need to find out the values of the constants a, b and c. So you can do this in two ways. The first method is the long division, and the second method is basically just solving this equation. The equating the coefficients. So Let's first use the second method. So we can write this equation as 4x cubed and plus 2x squared. So let me just write this down. So if we take x squared plus 4 as an LCM, this becomes ax times x squared plus 4 plus b times x squared plus 4 plus cx plus d. Alright, now these two cancels out, so the only thing we're left with is this one, 4x cubed plus 2x squared and plus 3x plus 8. So now let's just expand this, so this becomes ax cubed and 4ax, and this becomes bx squared plus 4b plus cx plus d. Now if we rearrange this, we can write this as ax cubed plus bx squared plus, if we take x common, this becomes 4a plus c x, and this becomes 4b plus d. Now these two are equal in values, obviously, because there is an equal sign in between them. Now what we can do is that we can equate the coefficients. We can say that a is equals to 4. So we can say that the value of a is 4, and then we can say that the value of b is 2. The value of b is 2. Now we just need to find out the value of c, so we can equate the coefficients of x. So we can say that 4a plus c is equals to 3. So 4a plus c, the value of a is 4 and the value of c is unknown. This is equals to 3. So the value of c will be negative 13. Now let's find out the value of d. Now we can say that this constant term is equals to this constant term. So it's basically 4b, the value of b is 2, 4b plus d is equals to 8. So the value of d is, so the value of d is basically 0. Okay. Okay, so that is it for this part. So this is the part A. So in the first part of part A, it asked us to find out the values of a, b and c, and the second part we need to show that d is equals to 0. Now hence, using algebraic integration, find this, giving your answer in the form p plus q ln 2. Now we cannot integrate this directly because it's impossible, but we can write this fraction in this format. So let's just use that. So let's break this down. So this becomes 1 and 4, and the fraction becomes ax, which is 4x, and plus b, so it's plus 2, and cx over x squared plus 4, so it's basically minus 13x over x squared plus 4 dx. Now the thing is that you can easily integrate these values but we don't know the integration of this. But there is a formula. So this formula is not listed in the book. This formula is not listed in the book. It's that if an equation is in this format, which is f prime x over dx, not dx, f prime x over fx. If you want to integrate an equation like this will be equal to ln fx. So it's not like this formula is not listed in the book. In the formula, in the book, there's only one single formula. It's that if you integrate 1 over x, this will be ln fx, ln x. But this is not the original formula. This is a derived formula. The main formula is this one. As you can see that in this equation, this fraction is in the form f prime x over dx. If you differentiate x, you will get 1. So that's why we were able to write this as ln x. Now if you want to apply this formula in this part, the thing is, if you differentiate this one, you get 2x, but there's 13 in this part. But this is a constant, we can change this, no problem. So what we can do is that we can write this as 13 over 2 times 2x over x squared plus 4 dx. Now we can easily integrate this, because if you multiply 13 over 2 by this fraction, the 2 cancels out and there's only 13x over x squared plus 4 remaining. Alright, now let's integrate this. So integrating this will give us 2x squared plus 2x minus 13 over 2 ln x squared plus 4. That's 1 and 4. We were able to bring this to a ln because this is in the form f prime x over fx format. If you differentiate this, you'll get 2x. So that's why we were able to use the ln. Now let's find out the values. So it's 2 times 4 square, which is 16, plus 2 times 4, which is 8, minus 13 over 2 ln 4 square, which is 16 plus 4, that gives us 20, minus the lower boundary. So minus 2 plus minus 2 and plus 13 over 2 ln 1 plus 4, which is 5. Right. Now let's simplify this. So this becomes 32. So it's 32 plus 8, 40. 40 minus 4, which is 36. Plus 13 over 2 ln 20. Ln 5. Okay, so no, we need this. Okay, so it's 13 over 2 ln 5 minus 13 over 2 on 20. So as you can see that the 13 over 2 is common, so we can take 13 over 2 common from this part, so this becomes this. Now as you can see that the value of, the base of log is the same. So since the base of the log is same, which means I can write it like ln 5 over 20, because as we know from the formula that if two logs have same bases and there's a minus sign in between them, you can write it like this, log a b over c. Right. So I can write it like 13 over 2 ln 5/20, which is 1/4. So that's basically 36 plus 30. Okay, so I think that's the answer. Okay, so P and Q are integers and there's a 2 at the front. Now what you can do is that you can bring this 1/2. I mean, there's 13 times 1/2, right? So you can bring this 1/2 to the front side. So this becomes 36 plus 13 ln 1/4 to the powered 1/2. Because we know that if there's a power on the power of a log, you can bring it like this. So this is basically root over. So it's 1/2. Now I can write 1/2 in this format, 2 to the power -1. Now if I bring this -1 to the front side, this becomes 36 minus 13 ln 2. So this is the answer for this question. So in the previous video we have solved the question 4 of P3 January 2025 session. So now let's move on to question 5. So a hot piece of metal is cooled by dropping it into water. The temperature H degrees Celsius of the metal T minutes after it is dropped into the water is modeled by the equation this. So first of all, we need to find the initial temperature of the piece of metal. So initial actually means the value of T is 0. The value of T is 0. So if the value of T is 0, we will get the initial temperature of the piece of metal. So if I substitute T equals 0 into the equation, we will get the initial temperature, which is the H naught, that is 280 e to the power 0, and e to the power anything to the power 0 is 1. So this becomes 1 plus 24. So the temperature is 304 degrees Celsius. Okay. Now for the second part, we need to sketch the graph of H against T. Now as you can see that this is an e to the power -x graph. So let's first consider the shape of the graph. So we know that y equals e to the power x. Let's say we have y equals e to the power x. So the shape of the graph should look something like this. If we have y equals e to the power -x, the shape of the graph will look like this. This is y equals e to the power -x. So now we know the shape of the graph. Now let's find out the individual values of the graph, and also there's an asymptote, which is y equals 0. Y equals 0. Why? Because there's a plus 0 at the end of the e to the power x. Okay. Now as you can see that the new asymptote will be y equals 24. So the new asymptote is y equals 24. And let's find this coordinate, I mean the y-intercept. At y-axis the value of x is 0. In this case the y-axis is h and the x-axis is t. So at h-axis the value of t is 0, which means the value of h is 304 degrees Celsius. So this will be our graph. Now as you can see that there are no values below t is less than 0 because time cannot be negative. And the horizontal asymptote is y equals 24 because there's a 24 at the end. So this is our final graph. Moving on to the next part, we need to show by differentiation that th over dt is a plus bh. So basically we need to differentiate this equation. So using a formula, we know that the derivative of e to the power ax should give us a e to the power ax. So the derivative of this should give us negative 0.05 e to the power negative 0.05 t. So let me just show this to you. Oh, okay, so let's move on with C first. In the part C, we need to show we need to find the value of t for which h is equals 144. So when the value of h is 144, we need to find out the value of t. So h is 144. The value of t is unknown. That's what we will find. So if we make e to the power negative 0.05 t the subject, we should get 120 over 180. So it's basically 12 over 18. Now if you take this e to the right hand side of the equation, this will become negative 0.05 t, and the right hand side of the equation will become log e 12 over 18. And we know that log base e can also be called as ln. So there's a formula, is that let's say we have a to the power x equals b. If you want to bring this base a to the right hand side of the equation, this will become log a b. So this is some kind of a formula, you can memorize this. Right, now if we make t the subject, you should get 16.95, and the unit will be in minutes because they have given the unit in minutes. So 16.95 minutes. Now let's move on to the next part, which is that we need to differentiate this equation. So if we differentiate this equation, so since this is a constant, you can leave it by the side. The derivative of this will be negative 0.05 t. So it's negative 0.05 times 280 e to the power negative 0.05 t, and the derivative of 24 is 0. So this becomes 0. Now we need to write down the answer in terms of h. Now we have 280 to the power negative 0.05 t in the equation already. Now if we make this the subject, 280 to the power negative 0.05 t, from this equation we will get h minus 24. So we can replace this value by h minus 24. So this will be h minus 24. So the final answer will be 1.2 negative 0.05 h. So that is it for this question, and I'll see you guys in the next question. So in the previous video we have solved the question 5 of P3 January 2025 session. Now let's move on to the question 6. So we have a function which is given to us, and the domain of the function is also given. So the domain is x cannot be negative 2. X cannot be 2. So first of all we need to find the inverse function. Now if you all watch the video on functions on exam essentials, this the part A and part B should be very clear to you on how to do it. So let me just walk you through this. That first of all we need to find the inverse function. So in order to find out the inverse function, we need to replace fx with y. So the first step is to replace fx with y. So this becomes y equals 4x plus 3 divided by x minus 2. Now the second step is to make x the subject. So if we make x the subject, so this is basic algebra, everyone should be able to do this. So if we make x the subject, this should give us an answer of x equals 2y plus 3 divided by y minus 4. Alright, so this is the end of the second step. Now the final step would be to replace x with f inverse x, I mean the inverse function, and replace y with x. So this will be 2x plus 3 over x minus 4. Now these are O-levels Maths B questions, but the difference between O-levels Maths B function and A-levels Maths B function is that I mean the A-levels P3 function is that you also need to state the domain of the inverse function right beside it. Like after finding out the inverse function, you need to write down the domain. So first of all, you need a third bracket. Now in order to find out the domain is that if we have a reciprocal function like this, you can say that the denominator cannot be 0. If we substitute the value of x equals 4 into this function, the denominator becomes 0. And the thing is that you cannot divide anything by 0. So we can say that x can be anything but 0. So x cannot be, x can be anything but 4. So that is the domain of the inverse function. Alright. Now the second question is that we need to find the composite function if fx, which means that the fx function is being substituted into the fx function itself. So it's basically, we can write it like this. So I have talked about the composite functions in my functions video on Exam Essentials. Please look at it if you are still confused about functions. So at x we will substitute the function fx, which is 4x plus 3 divided by x minus 2 plus 3. So again, in terms of x, we will write the function 4x plus 3 divided by x minus 2 and minus 2. Now what we can do is that multiply this whole fraction, the numerator by x minus 2 and the denominator by x minus 2 also, in order to get rid of these. So this will be equal to 4 times 4x plus 3 plus 3 times x minus 2 divided by 4x plus 3 minus 2 times x minus 2. So if we expand this, that's 4x plus 3 minus 2x plus 4. So finally we have an equation which looks something like this. There's 19x plus 6 over 2x plus 7. So this is basically the composite function. So that is it for this part. Now moving on to the third part, the point P 315 lies on the curve with equation y equals fx. Find the point to which P is mapped when fx is transformed to the curve with equation y equal twice of f3x plus 8. Okay, so again, calling back my other video on the functions, on Exam Essentials YouTube channel, there's a video called Transformations Modulus Function and function. So in that video I have talked about functions, and both functions and transformations. So if you all saw that video, you must be clear about what they're talking about in this part. So if 3x, let's talk about this. 3x actually means that the x coordinates are divided by 3. So the new coordinate of point P will be, let's say that the new coordinate is P prime. So the new coordinate is P prime. So the x coordinates are divided by 3, right? And then there's a 2 at the front, which means that the y coordinate is multiplied by 2. And there's a plus 8, which means that the y coordinate, 8 is added to the y coordinate. So this can be written as 1 and 38. So this is the coordinate there they want you to find out. So that is the answer for part C. So in the previous video I have solved the question 6 of P3 January 2025 session. Now let's move on with question 7. So given that a and b are positive constants with a is greater than b, sketch on separate diagrams the graph with equation this. Okay, so this is a modulus function. So if you guys all watched the modulus function video on the exam essentials, this should be clear to you. So in order to draw the modulus function, the first step is to find out the coordinates of the vertex. So the coordinates of the vertex, in order to find out the coordinates of the vertex, take the function inside the modulus and equate this to 0. Equate this to 0, so x will be equals to a over 3. Now we need to find out the minimum, the value of y, the y coordinate of the vertex. Now as you can see that there's a plus 0 in the equation, so this is the y coordinate of the vertex. Now if we sketch this graph, okay, so another thing we need to show on our sketch is the coordinates of the point at which the graph crosses the y-axis. So we know that at y-axis the value of x is 0, so this will be 0 minus a, so it's basically minus a, so this is equals to a. So we have one coordinate which is a over 3 and 0, and the other coordinate, this is the coordinate of the vertex, and the other coordinate is 0 and a, which is the y-intercept. Now we can easily sketch this graph, and we need to sketch on separate diagrams. So let's say that at this point the x coordinate is a over 3, and at this point the y coordinate is a. So the graph should look something like this. So this is the y equals 3x minus a graph. Now for the second graph, let me just erase this. Now for the second graph, let's first find out the coordinates of the vertex of this graph. So the coordinates of the vertex will be 3x minus a equals 0. So this is basically the same thing, which is x equals a over 3. Now when the value of x is a over 3, we need to find out the y coordinate. So if we substitute x over 3, a over 3 into this equation, this will give us a minus a and minus b. So the y coordinate is negative b. So the coordinate of the vertex is a over 3 and negative b. Alright. or you can think of it like this, that the y coordinate of the vertex is the constant right beside it, right beside the modulus function. So this is the y coordinate of the vertex. Now at y-axis the value of x is 0. So if we substitute x equals 0 into this equation, this will give us 0 minus a minus b. So it basically gives us a minus b. So this is the y coordinate of the y-intercept of the graph. Now if we sketch this, so the coordinates of the vertex are a over 3 and minus b. So let's say that it is at this point, and the y-intercept is a minus b. Let's say that it is at this point. So the graph should look something like this. So this is a minus b, and this is a over 3 and minus b. So that's a over 3 and minus b. So that is it for this part. Now in the second part we need to solve the equation this is equals to this. So this basically means that y equals 5x intersects y equals 3x minus a modulus minus b. Y equals to this. So it basically, the equation y equal 5x intersects with this graph. So it can either intersect like this, or it can either intersect like this. So there can be one value only, or there can be two values. So let's solve the equation. So when solving these modulus equations, you need to keep in mind that sometimes you also need to take help from the graph. In this case, let's say we get two values, but it intersects at this point only. So there will be only one value of x. So if the graph looks like this, there will be two values of x. So we'll explain this later on, but let's just solve the equation. Now if you guys saw my previous video, it's a very old video on the modulus function. On that video I talked about how to solve modulus equations. So let's assume that we have the equation 3x minus a and minus b equals 5x. So the first step is to bring everything which is not a modulus function to the other side of the equation, and keep the modulus function as an individual on one side of the equation. So this becomes b plus 5x. Now what you need to do is that the first thing you need to do is that take this value as positive. I mean, take it as it is. So this will be 3x minus a equals b plus 5x. Now make x the subject. So making x the subject should give us minus a minus b over 2. So this is one solution. Now the second solution is to take this whole value as a negative value. So this becomes minus 3x minus a equals b plus 5x. So if we rearrange this, this will be a minus 3x. Now let's make x the subject. So making x the subject should give us a minus b over 8. And we have to keep in mind that a is greater than b. Now let's determine which is the actual solution. Now as you can see that the first solution we got, this gives us a negative value of x. Now if we look at the graph again, the negative value of x actually means this quadrant, I mean this part, these two quadrants. As you can see that in these two quadrants the two graphs does not intersect in any way. So you can think of it like this, that the graph may look like this. This can be y equals 5x, or this can be y equals 5x. Neither of these graphs intersect in these two quadrants. So you can say that x cannot be negative a plus b over 2. So the only solution is this one. So this is how you actually determine which one is the actual solution of your equation, I mean actual solution of your graph. So that is it for this question. I hope you all understood the video, and I'll see you guys in the next video. Assalamu alaikum everyone. So in the previous video we have solved the question 7 of P3 January 2025 session. Let's move on to question 8 of the paper. So in the first question they have asked us to solve this equation, and the range of theta is given. So what we can do is that we can write cosec theta as 1 over sine theta. So if we apply this will be 3 over sine theta equals 8 cos theta. If we bring the sine theta to the right hand side of the equation, this becomes 8 sine theta cos theta. And from a trigonometric identity we know that 2 sine theta and cos theta is equals to sine twice of theta. So if we take 4 common from this part, this becomes 2 sine theta cos theta, and we can replace this with sine 2 theta. So it's 4 sine 2 theta. So the value of sine 2 theta is 3 over 4. Now the range of theta is given, but we need the range of 2 theta. So basically what we need to do is that multiply this whole equation by 2. I mean multiply this whole inequality by 2. So this becomes 0 and 2 theta and 2 pi. So in order to solve these equations, what we will do is that in our calculator write down sine inverse 3 over 4. So this gives us a value of 0.848 radians. And then what you need to do is that draw the gas diagram. So the gas diagram looks like this. So this is A, C, T, S. This is theta, and this is 2 pi minus theta, and this is pi plus theta, and this is pi minus theta. Now in this case the value of sine is positive, as we can see from the equation. The value of sine is positive, which means that our solution lies in these two quadrants, this one and this one, because in these two quadrants the value of sine is positive. So theta itself is the solution, which is this one is itself the solution. So the value of 2 theta is equals to 0.848, and the other solution will be pi minus 0.848. So pi minus, which gives us a value of 2.294. Now there are also other solutions, but the thing is that if you add 2 pi to this value, you will get the next solution. But the thing is, the next solution will not be in range. So these are the only two solutions for our equation, which is 0.424 and the other one is 1.15. So that is it for the first part of the question. Now for the second part, we need to solve this equation, and the range is given. Range of x is given in degrees. Now as you can see that this value is in the form tan A minus tan B over 1 plus tan A tan B. This expression is in this form, which means that I can write it in this format because this is a trigonometric identity. You guys need to memorize this, or this is also given in the formula booklet of your answer script. Okay, so we can replace this with tan 2x minus 70. So we can say that tan 2x minus 70 is equals to negative 3 over 8. Now the thing is, we need the range for 2x minus 70. We have the range for x only, which means that we need to multiply this whole equation by 2. So 0, 2x and 360. And then we need to subtract 70. So this becomes negative 70 and 2x minus 70. So this becomes 290. So 360 minus 70, yep, that's 290. So this is our final range. So now it will be much easier for us to find out the solutions. Now what we need to do is that, first of all, completely ignore the negative sign. In your calculator, write down this value, substitute this value. So this gives us a value of tan inverse 3 over 8. So this gives us 20.56 degrees. Keep in mind that this is not our solution. Our solution, we will determine our solution from the CAS diagram. So in the CAS diagram, in this part, the value of tan is negative, which means that it will lie on these two quadrants, this one and this one. Our solution lies on these two quadrants. So okay, so this is pi, which means this is 180 minus theta, because our answer will be in degrees. So that's 360 minus theta. So one of the solutions will be 180 minus theta, that is 180 minus 20.56, which is 159.44 degrees. So one of the solutions is 159.44 degrees. Now the other solution will be 360 minus theta, that is 360 minus 20.56, which is 339.44 339.44 degrees. Now but the thing is that this solution is not in range. Now if you subtract 360 degrees from this solution, you will get the previous solution. If you guys are watching this video, which means that you have somewhat of a good knowledge to solve trigonometric equations, like how to solve trigonometric equations. If you don't, I will make a video on it if you guys want. So if we subtract 360 from this, we will get negative 20.56 degrees, which is in range. and then just erase this solution. So one of the solutions will be is 24.7 degrees, 24.7 degrees, and the other solution is 114.7 degrees. So that is the answer for this question, and I'll see you guys in the next question.
Are you guys still stuck in chapter 1 while the exams are racing closer? Are you guys still watching videos on YouTube but your marks are not increasing? It's not you actually, it's the method. Let's fix it. Welcome to Exam Essentials, where every second counts and every session hits. You have seen the paper solving videos, right? And you have watched the YouTube walkthroughs as well. Now it's time to do the full course with us, this time for real. So basically, we have launched our A levels high impact crash course for the October 2025 and the Jan 2026 session for the subjects mentioned below, which are physics, chemistry, maths, biology, economics, business, information technology, and accounting. Now let's know what is included in these courses that we are offering to you guys. So in the month 1 and month 2, basically there we will complete the full syllabus. Let's say if you are an AS physics candidate, we will complete the syllabus of unit 1 and unit 2 in month 1 and 2. And if you are an A2 physics candidate, we will complete unit 4 and unit 5 on month 1 and 2. We will complete the syllabus in detail using our AI generated videos as well as simulations to make you guys understand tricky stuffs very easily. And then what we'll be doing? We'll be doing intensive past paper solving from all the recent question papers from Jan 2020 to Jan 2025 on the upcoming months, which is the month number 3 and 4. And this is not only the things that we'll be getting, there will be a few more things as well. The thing is, you will get the access to 50 plus previously recorded question paper solving videos. You have watched my question paper solving videos on YouTube, right? But there are 50 more question paper solving unlisted videos of mine, which you guys will get after joining my course. That is not in the YouTube. As well as those videos, you guys will also get my digital notes, my mega revision worksheets, which works like a magic. The mega revision worksheets are just a magic, and a few more things as well, supplements and worksheet booklets and many more things. And here you guys will also get the live and recorded sessions. The classes, you guys will get around 3 classes every week, which will be around 1.5 hours. So you will get the videos of those classes as well, which you guys can rewatch anytime. And I will be available for you guys 24 hours 7 days. You guys can ask me any questions in our WhatsApp group or Messenger group. I'll be there to answer your questions. Now, why will you actually join my courses? You guys have watched my video and you have enjoyed my video, but why will you guys join my course? Because the result of my students speaks for themselves. So basically you guys can check the recent results of my students. So basically don't waste your time anymore. Join my course to excel in A levels physics. You can contact me on my Facebook page Exam Essentials or at my WhatsApp number, which is given right here.
So in the previous question, we have solved the question 8 of P3 January 2025 session. Now let's move on to question 9. So we have a function which has the equation 6 root over x ln 4x. Now the curve cuts the x-axis at the point P. Okay, so at this point, so it's not only at point P, the curve cuts the x-axis at 2 of these points. Okay, we just need to state the x-coordinate of P. We know that at x-axis the value of y is 0. So we can say that 0 equals 6 root over x ln 4x. Now we know that one of the solutions will be x equals 0 from this part, and the other solution will be ln 4x equals 0. Now if you bring ln to the right hand side of the equation, this becomes e to the power 0, because we know that ln is equals to log e. Log e for x equals 0. So if you bring the base to the right hand side of the equation, this becomes e to the power 0. This is a formula. So the value of x is 1 over 4. So this is the x coordinate of e. Okay. Now for the second part, the point Q is the stationary point on C. Use calculus to find the exact coordinates of Q. Okay, so we need to use the calculus. Alright. Okay, so basically at point Q, the value of dy over dx is 0. Dy over dx is 0. So at point Q, the value of dy over dx is 0. So which means we need to differentiate this equation. So we have to use the product rule, which means that this is our one of the functions, which is, let's call this function u, and let's call this function v. Alright. Now I hope you guys know how to differentiate ln functions. If there's a function which looks like this, that is ln fx, if you differentiate this, you will get f prime x over fx. So which means if I differentiate ln 4x, I will get 4 over 4x. I will get 4 over 4x, which is equals to 1 over x. So that is the derivative of ln 4x. Okay. So using the product rule, we know that the product rule states u dv over dx plus v du over dx. So it's basically 6 root over x dv over dx. The derivative of ln 4x is 1 over x plus v, which is ln 4x, du over dx. Okay, so now let's differentiate 6 root over x. So 6 root over x is 6x to the power 0.5. If we differentiate this, the power will come to the front side, so this will be 0.5 times 6 times x to the power, and you need to subtract 1 from the power, so this becomes negative 0.5. So this is basically 3x to the power negative 0.5. So this is the derivative of 6 root over x. You can also write this as 3 over root x. So this can be written as 3 over root x equals 0. Now let's let's multiply this. Since this is an equation, we can multiply this whole equation by root over x, because I want to get rid of this one. So if I multiply the left hand side by root over x, I also need to multiply the right hand side by root over x. So if I multiply root over x by this term, this will become 6x times 6x times 1 over x plus 3 ln 4x equals 0. Now this is a much simpler equation. These x's will cancel out each other, and finally we have 3 ln 4x equals -6, and ln 4x equals -2. And if I bring this ln to the right hand side of the equation, this will become e to the power -2. Now if I make x the subject, this will be e to the power 1 over 4 e to the power -2. Or you can also write it like this, 1 over 4 e squared. So that is the x coordinate of point P. Now we need to find the y coordinate of point P, because they have told us to find the exact coordinates of Q. Now if I substitute the value of x, I mean the x coordinate of point Q, into this equation, I will get the value of y. So it will be if 1 over 4 e squared is equals to 6 over 1. So this becomes, you can cancel out this one, and this becomes 6 times 1 over 2e times ln e to the power -2. And I can write this as 3. Oh wait, can cancel out this 3. And we know that the value of ln e to the power -2 is -2. So we have a final value of -6 over e. So that's the y coordinate of point Q. So we know that the coordinates of point Q are 1 over 4 e squared and -6 over e. So that is it for this part. Now moving on to the next part, we need to find the range of the function gx, where gx equals -2 if x. Okay, so the range of function fx will be if x is greater than or equal to this value, I mean the y coordinate of q. So the y coordinate of q was -6 over e. So the range of fx is -6 over e. Now gx is a function such that gx is equal to -2 fx. So -2 fx, so which means that, first of all, let's just consider this part twice of fx, which means that the y coordinate is doubled. So the new graph will be, I mean the new coordinate of q will be -12 over e. Now the second thing is that there's a negative sign at the front. Now if you guys watched my video on transformations and functions, this should be clear to you all, that if there's a negative sign at the front, it will be the whole graph will be reflected in the x-axis. So the new graph will look something like this. So the new coordinate of q will be 12 over e. Since the new graph looks like this, we can say that the range of gx will be less than or equal to 12 over e, because there are no values above 12 over e. So this is the answer for this question, and I'll see you guys in the next question. So in the previous video we have solved the question 9 of P3 January 2025 session, Now let's move on to question 10, which is the last question of this paper. So we have a sketch of a curve with equation x equals 3 cos 2y. Now we need to find dx over dy in terms of y. Okay. So basically we need to differentiate this equation. We usually differentiate it like dy over dx, but now since x is the subject of the equation, this will be dx over dy. So dx over dy will be, and we know that the derivative of, let's say we have cos ax, where a is a constant, the derivative of this will be minus a sine ax. So the derivative of this will be minus 3. So the 3 is a constant, so you can leave it by the side. So this will be minus 3 times 2 times sine 2y. So this becomes negative 6 sine 2y. So that is it for this part. Now in the next part we need to show that dy over dx is equals to this value. So we need to show that it in terms of x only, there will not be any y. So there's a constant and there's an x. There is no y in the equation. Now if you want to show dy over dx, we know that dy over dx is basically the inverse of dx over dy. So basically if you flip this value, you will get dy over dx. So this will be negative 1 over 6 sine 2y. Now let's see how we can write this in terms of x only. Sine 2y. So if we want to replace sine 2y with x, okay, so there's an x squared, so this equation will be squared. So if we square this, this will be x squared equals 9 cos squared 2y, and we can write cos y as 1 minus sine squared 2y, because of the identity sine squared x plus cos squared x equals 1. Now if we make sine squared 2y the subject, this will be sine squared 2y equals 9 minus x squared over 9. So this is the sine squared, we can write sine squared 2y as 9 minus x squared over 9, or you can also write this as 1 minus x squared over 9. So it's up to you. Let's say I want to keep it like this. Now if we replace, so this is the value of sine squared 2y, we need the value of sine 2y, so basically we need to root over this whole thing. So this becomes, okay, so this becomes 3 and there's a root over at the front, so this is basically 1 over 3 root over 9 minus x squared. So we can replace sine 2y with 6 times 1 over 3 root over 9 minus x squared. So this gives us a value of negative 1 over 2 root over 9 minus x squared. So this is the answer for this part. Now moving on to the next part, the point A, B lies on the curve and is shown in figure 2. Okay. So this is point B, which has coordinates A and B. The gradient of the curve at P is negative 1 over 4. Okay, so we have an information that the value of dy over dx at x equals A is 1 over 4. negative 1 over 4. So from this we can find out the value of a. So we know that dy over dx at x equals a is negative 1 over 4. So this is minus 1 over 2 root over 9 minus a squared equals negative 1 over 4. So we can cancel out the negative signs and we can cancel out this with this. So this becomes 1 over 2. Now if we cross multiply this equation, so this will be 2 equals root over 9 minus a squared. And we know that both a and b are positive. So the value of a will be 4 equals 9 minus a squared. So a will be root over 5. We need to find the exact value, so a is equals to root over 5. Now from this, so from this we can find out the value of b, because b is the y coordinate. Since point P lies on this curve, which means we can substitute the x coordinate into this equation. From this we can find out the y coordinate of P. So we know that the x coordinate is root over 5 and the y coordinate is b. Now we just need to find out this value of b. So if we solve this, so cos twice of b is root over 5 by 3. So since we need to find the exact value of b also, so this will be twice of b equals r cos x. Okay, so r cos x equals root over 5 by 3. And since there's a 2 at the front, we can bring this 2 to the right hand side of the equation, so this becomes 1 over 2, which is r cos x. So this is the exact value of a and b, and that is it for this question. So I hope you guys enjoyed the whole paper walkthrough. And I'll see you guys in the next video.